Hello and how are you? Welcome to this tutorial in which we are still handling calculus and which we basically also have. It has a basic large umbrella which we call elementary calculus, and I am your tutor Joseph Adeli, which I shall be able to be tutoring you at this particular tutorial. Before we begin, let's humble ourselves for the word of prayer. Father, Lord in heaven, we invite you in this session that you are able to teach us what you have for us in this particular session. In Jesus' name I pray, amen. Directly to differentiation, because it's still what we are handling in this particular session, and by the end of this topic you should be able to find rates of change. You should be able to, let me just list them, all of them here, and then I tell you what I'm going to do in this particular tutorial and what we have covered. Rates of change, that's the first one you have done. Finding the gradient at a point using a tangent is also done. You also know how to relate the delta notation to rates of change. Find the gradient of a function of the form y is equals to x power n, of which n is a positive integer. You have also done finding the gradient of which you have a negative integer. You have been able also to define a function, a derived function of a polynomial, and differentiation of which it was covered when you are working with different notations of differentiation. You are also able to determine the derivative of polynomial, and also you are capable of finding equations of tangents and normals to curves. Now in this session we are going to learn how to sketch a curve. Then in the next tutorial we shall cover the last two objectives, and then we shall call it a session. Now to curve sketching, I shall want to begin with a quick question so that you're able to learn from it. Find the gradient of y is equals to 2x squared at a point x is equals to 0. Now there's something I would like us to discover from this particular point that shall help us in our learning about curve sketching. From the name itself, curve sketching, we don't have all the details to okay, let me not say all the details, because like for example by the end of this tutorial you shall learn how the format of a question is usually given. You are given all the details, by the way. You are given an equation of a curve, so using that equation you can accurately draw that curve, but you have just been told sketch it. Means give us an idea of how that curve shall look like. For example, its nature. Is it a maximum curve? Does it have maximum points, minimum points? It simply means, for example, if you have done physics or you are taking physics, you find that you can look at a wave and be able to define it in terms of crests and troughs. So in such a case, if I'm drawing a curve, does it have crests? That's what I call maximum points, or troughs, minimum points. How does it look like? Or is it a point of inflection? So such is what we mean by curve sketching. It means you are giving us an idea of what is the most finer detail. So if you don't mind, you can pause the video and be able to work this one out. Now I believe you have something at hand. Find the gradient at that point. Basically begin by finding the gradient function, which is basically dy over dx is equals to 4x. That is your gradient function. But now you have to find the gradient at a point x is equals to 0. So if you substitute at x equals to 0, find that the gradient is 0. Ooh, the gradient is 0. Now, what does it mean to have a gradient of 0? Now, notice something. If the gradient of the function y is equals to x power n is 0, it means that the curve is turning. The curve is turning. The curve is turning. Please note that point. The curve is turning. This point on the curve is called the turning point, or basically stationary point. Now let us be able to see a grammatical representation of this particular turning point of what I simply mean that the curve is turning. So at stationary or turning point, the gradient is usually 0. Now if I have my curve like that, the turning point is basically this point here. If I have my tangent there, and then I decide to get the gradient of this tangent touching at the point I'm calling turning point, let's prove that this is the gradient. If I basically extrapolate there, for example, I may assume this particular point to be negative 3, 4. And then the other point I can assume it to be 2, 4. Because you basically notice that it's lying on the same point on the y-axis. So you can notice that 4 is common for the y-axis because it doesn't change, but what changes is on the x-axis. So you switch to x-axis. So we have negative 3 and 2. So if I get the gradient, you know that the gradient is usually changing over change in x, which basically gives us 0 divided by 5. Now, 0 divided by any number is 0. So the gradient of any line parallel to the x-axis is 0. So that tells us that this tangent touching at the turning point, and we noticed that from equations of tangents, the tangent is usually with an equal gradient with the point at which it touches, because they are parallel. And this one was explained in the previous tutorial. If you don't remember that, or you have not grasped it well, please go back to that tutorial, get the concept, work on numerous questions as possible that you can find. If not, please contact me so that I'm able to get you more. So that is basically what we have at that particular point. But this is not the only way we may have a turning point. We have a turning point, for example, in this manner, whereby now the turning point is facing this direction. That's what we can have. So let's, for example, identify what this particular means. Now notice I've already told you what the gradient is. I've already told you that the gradient is infinity. It's not 0. The gradient is infinity. It's very big that you cannot get it. So let us prove it to be so. If I extrapolate my points, I can assume that to be negative 3, 3, and this other one to be negative 3, negative 4. So if I get my gradient, you'll find that it is a number divided by 0. Now, to prove that we are having an infinite number, divide 7 by negative 1. You'll notice that you will be having 7. And then divided by 0.9, 0.8, negative 0.8 up until you approach 0. You'll notice that it's approaching a very big number. What do I basically mean? Let us go step by step. I've just said a lot of things. Divide the following number, that we have 7 divided by 0. Now, let us pick numbers that are very close to 0 on both sides. Let us start from 0.5, because that is quite closer. With your calculator, I believe you are with me. If not, please pick a calculator, because I don't have this one on the slides. I'll be punching it, and then you'll be following also with your calculator. Notice if I have 7 divided by 0.5, my number will be 14. So far, so good. If I divide it by 0.4, it goes to 17.5. If I divide 7 by 0.3, it comes to 23.3333 recurring. If I divide 7, the same 7 divided by 0.2, I'll get 35. Now the number is increasing. And infinite, we basically said it's a very big number. 7 divided by 0.1 will basically have it as 70. Now, let us assume, because the next number obviously is 0. If you basically just be wild and say 7 divided by 0 in your calculator, you'll get a math error. Why? It's a very big number. The calculator cannot determine it. So let us assume we had 0.1. Then let's say we are dividing it by 0.01. You'll get 700. Divide 7 now by 0.001. You'll get 7,000. So the number is keeping on increasing. You can continue like that until you get tired. if we do that from both sides, you'll find that is the case. So the number tending to 0 is very big. To give you a hint, in calculus we call that limit. So the limit as x tends to 0 is infinity. So that is the case, but that's just, it's not at your level. I've just decided to tell you that. But if you are if you really want to know more about that, please get in touch so that I'm able to teach you more of what is happening with that, of what are called limits. You shall not meet them in high school, but you shall meet them in campus. So those are the two types of turning points that are very common to you. But in calculus, as you are beginning this tutorial, basically, you noticed that I said some number of turning points. It might be a maximum point, it might be a minimum point, and I said something else called point of inflection. Let us see the nature of each one of them so that you're able to understand what is happening. So this one is just a matter of explaining that you may have a maximum and a minimum point. Now let us look at various examples of natures of turning points. At first, let us look at this. You may have your axis like that, draw a curve. Now, I would like us to analyze this particular curve. It's going up like that. It's what we call a maximum point. Now, how can you define a maximum point, or how can you get this to be a maximum point? There are some various things you shall look at, the nature of that curve, in fact. So we shall start from either side. For me, I like citing it from the left-hand side to the right-hand side. So analyzing from the right-hand side, that's very important for curve sketching, so please take note. You basically start analyzing from one side to the other side. So from my right hand side, if I have a point moving upwards like that, you notice that this is somehow like a parallel line to the curve, or a straight line that I can draw it like that. And this straight line has a positive gradient, sorry. So it has a positive gradient, notice. Then next, I can represent this particular turning point here the moment I reach the top by a straight line, because it's parallel to that specific point. The gradient is equal. So the gradient at this particular straight line is 0. We have proved that. Similarly, if I go downwards to the right hand side, this gradient is negative. So maximum point bears the following nature of points. It starts with a positive gradient, then to a 0 gradient, then a negative gradient. Positive gradient, 0 gradient, negative gradient. That's a maximum point. So if you want to curve sketch, you have to know if it's a maximum point, this is what should be in your mind. Positive gradient, 0, and then negative gradient. Let's look at another type of a point. Here we are going to have a minimum point. Now minimum point is basically now the inverse of a maximum point. It begins with a negative gradient as I move along this line, then to a 0 gradient line at the turning point, then positive gradient as it goes up. So it's something like a trough. So this trough bears a negative gradient, then 0 at the turning point, then positive. So basically a minimum point, it starts with a negative gradient, then 0 gradient, then positive gradient. That's a minimum point. Please have these things in mind, or find a way of grasping it, but it's basically a concept. You can even, if you forget them, just curve sketch and then deduce the points that you require to remember. Next, here we are having now points of inflection. A point of inflection is basically if I have a point that somehow it's stretched upwards, it doesn't form a full-fledged curve. In most cases, when you have points of inflection, you have something called an asymptote. I believe you should be quite acquainted with an asymptote. If not, we shall be able to solve that one later. It's not in this particular tutorial. Most of the times in high school, you shall not meet asymptotes. But if you go to, which topic is this one? quadratic equations whereby you shall be dealing with trigonometry, you must have met asymptotes. So I believe you know what the asymptotes are. Asymptotes basically, I can just give you a hint of what is happening here. Asymptote is basically a line that is very close to let me say, hey, I'll be defining a particular term with another term. Now, an asymptote is basically an imaginary line that is very close to a line that is drawn but does not touch it. That's something you need to note. For example, if I have my an asymptote here like this one can be an example of an asymptote because this line does not touch. Even at infinity, they'll never touch. So sorry for this. So asymptotes never touch the line. So let's analyze this particular point of inflection. You notice that it starts at this point with a positive gradient. Then at the point of inflection, the gradient is 0. Then afterwards, the gradient is positive. So it's positive, 0, positive. So it means this type of point of inflection, it has a positive, 0, positive gradient. Aha. What of another type of point of inflection? This one has a negative gradient, 0 gradient, then negative gradient. So it means point of inflection have two ways of occurring, either positive, 0, positive, or negative, 0, negative. Please note, what I'm calling here positive and negative, are basically gradients or 0. So this is just a way of analyzing the gradients of a particular point or a particular curve at a turning point. Let's learn about test of stationary points now. Now, to test any stationary point is to ascertain whether the turning point is maximum or minimum or a point of inflection. That's basically what entails test of stationary points. There are basically two methods of doing this. One is analysis of the nature of the turning point. Another one is the use of the second derivative. Now let's begin with the first one, analysis of the nature of the turning point. This method analyzes the nature of the turning point plus two adjacent points of the turning point. What do I mean? If you have a turning point, I'll basically pick one point on the left of the turning point and the other one on the right of the turning point. It means I'm extending further on that particular curve, picking two extra points to be able to analyze the nature of that particular turning point. So the steps of doing this is basically determine the gradient function of the equation of the curve. Number 2, determine the turning point. Then choose any one point of your choice on both sides of the turning point from the independent axis. So basically, most of the time, the independent axis is usually x. So you pick other two extra points apart from the turning point that are adjacent to that turning point, both on the from both sides. Then sketch the gradient nature of each side of the curve approaching the turning point. Now, this is where the previous knowledge comes handy, whereby you know if you find that the turning point is a maximum point, you know that it will be positive gradient, 0 gradient, 0 gradient, then negative gradient. If it's a point of inflection, what do you expect? If it's a minimum point, you know that it's negative gradient, 0, positive gradient. Note below, this procedure is done for all the turning points that a curve has. Now you may note that other curves, for example cubic graphs, have two turning points. If you have a graph with, for example, those are the basic two ones that you'll be drawing. But if you have 2 turning points, 3 turning points, you have to do these particular steps for each one of them. Let's get examples. Find the turning point of the curve y is equals to 2x squared and ascertain its nature. Two questions in one. I would like you to from what we have just basically gotten, try working on this particular question and be able to have something at hand before I basically give you what I have. Now, believing that you have something at hand, let us get down to work. The first thing is getting the gradient function, which is dy over dx is equals to 4x. Then, at the turning point, which we don't know, we are looking for that turning point, the gradient must be 0. So if I equate that working for x, x will be equal to 0. So it means the turning point has its x coordinate as 0. That is something we need to know. But now, we said last time that if you have a particular one coordinate, that particular point, the gradient might not be 0 because the y coordinate will be along that particular vertical line. For example, my x is equals to 0 at this particular point. Notice, even here is x equals to 0, even here is x equals to 0, but the gradient will not be the same at those other points. So we have to find the exact position of the y coordinate, and that one is gotten by substituting the x value into the original equation of the function, of which our function was y is equals to 2x squared. So if I substitute for x, so at x equals to 0, y will be equal to 0, 2, because if I substitute there, 0 squared is just 0, multiplied by 2 is 0, so y will be equal to 0. So my turning point is 0, 0, basically the origin. So we have answered the first part of the equation. Now the second part, let's ascertain its nature. When ascertaining its nature, we basically come up with a table, and that table, you find that in the first column you will have your x coordinates. So in this first row you'll have x coordinates. In the second row you'll have the gradients of each particular point that you have stated here, and then finally you'll have its nature drawn below here. So in this particular first point, I'll include my point. So the middle point will be my turning point, of which here I'm working with the x values. So x values, the x coordinate is 0. Then adjacent to it on the left hand side is -1, and adjacent to it on the right hand side is 1. Substituting that into my gradient function, I'll find the following. That in the first case, I'll find that my gradient will be -4. The second case, my gradient will be 0. And then at point 1, my gradient will be +4. If I draw the natures of each one of them, I'll find the following. That this will be the negative gradient, this is 0, and this is positive. What does that tell you? The turning point looks like this. And what did we call that point to be? We said that that is a minimum point. So basically the turning point 0, 0 is a minimum point. Let's get another example. Find the turning point of the curve y is equals to 1/3 x cubed minus 1/2 x squared minus 2x, and ascertain its nature. Still the same thing. Now from what you have basically done, could you also attempt this question before we do it together? Now the next thing that you'll get from this point, you first start by getting the gradient function, which is x squared minus x is minus 2. You know how each of those things come about. So at the turning point, the gradient should be equal to 0. Solve that quadratic equation, you'll find that the first coordinate of x is 2. The second coordinate is -1. If you don't know how to do those solve quadratic equations, please review that. It will be quite dangerous to be able to go ahead and you don't know how to apply that here. You can use the quadratic formula, you can use solving by matrix method, you can also use substitution method, you can use simultaneous, you can use elimination method. The only one that may give you a challenge, but if you have a graph, you can use graphical method. So all the 4 methods are applicable. So at the first point, notice now we have two turning points in this case. So we have x at x is equals to 2 and x is equals to -1. So we are going to do for both of them. So at x is equals to 2, you find that the y the y coordinate will be -3 and a third. What about at x is equals to the second coordinate of x? Find that the second coordinate of y will be equal to 1 and 1/6. Now notice I've written it in the fraction form. Reason being, these particular values are recurring. Once you find a recurring fraction, a recurring number, you basically write it as a mixed fraction, a recurring decimal, sorry. You write it as a mixed fraction because we don't want errors errors due to approximation, unless you have been told rewrite it now to this number of decimal places. But if it's open-ended like this, write it in a mixed fraction. So the points, basically, you'll find that the turning points are basically 2 and -3 and a third, and -1, 1/6. Those are the turning points. Now we have to ascertain the nature of each of these 2 points. That's why we come up with 2 tables, similarly to what we had previously. So the first table is at x equals to 2. The second one is at x is equals to -1. Let's do the first table, and then you try the second table, though I believe you know how to work it out and you have worked it out too. What you'll have the following is this. If I substitute my values there, my nature will be a minimum point for at x is equals to 2. And at x is equals to -1, you'll have a maximum point, which is that. So you'll find that the turning point at that point is a maximum point. Now there's a second method that I said we can use to be able to work out for testing stationary points, or basic the nature. It's what we term as use of the second derivative. So in this step, as the title suggests, you work out for the nature of the turning point by getting the second derivative, or basically I mean differentiating twice. So if I differentiate the first time, I get a gradient function. I differentiate the second time that same gradient function to another point. So let's get the steps of solving this. The first thing is getting the second derivative of the function given. And I believe when you are solving out for answering the question why we have different notations of differentiation or derivatives, we came across this, and we said that this one is whereby you have this as the second derivative. So it means I get my first derivative dy over dx, and then differentiate again dy over dx to get d squared y over dx squared. With the time, we shall be able to understand why we have it in this particular format. Then step number 2, compare with the following constants. 1, if you find that your second derivative is less than 1, then the point is a maximum point. If you find that the second derivative is greater than 1, then the point is a minimum point. Now, let us make things easier. Don't cram. Understand the concept. If your second derivative is less than 1, think of it in terms of greater things. They are inversely proportional. So, if it is greater than 1, think of it in a minimum point, inversely proportional. Makes sense? I suppose so. Now, note something. The second derivative cannot and is never equal to 0. For example, the simplest curve you'll ever have is y is equals to x squared, of which the second derivative is 2. I believe you can differentiate it the first time dy over dx, you'll get 2x. If you differentiate the second time, you'll get 2. So that is the simplest curve. So in this case, you find that it's 2. So 2 is greater than 1. So if it's greater than 1, the turning point of this curve will be a minimum point. So you'll have such a thing like this. You can even prove it. It's a very short way like that. Now, somebody else who is cheeky will end up saying, now, teacher, what if I have y is equals to x? Now, And no sane man will just disturb himself and saying, I want to differentiate this twice. Because in this case, if I differentiate dy over dx, this is basically the gradient. Which we term as m. Sorry for all those nasty works. This is basically the gradient. Why should we differentiate the second time? Are we looking for the nature? No. Differentiate the second time, you'll end up with 0. Because if you differentiate the first time this, you'll find that this one will be equal to 1. Now, if that is 1, differentiate the second time, you'll find that there's a next component here, but it's raised to power 0. Now, since it's raised to power 0, your second derivative, which is d squared or all of that, will be equal to 0. And then you'll say, now you see, you told us a lie. Please. This method is used for determining the nature of stationary points, not just differentiating things. I know it can be equal to 0, but this particular way of determining stationary points, it can never be equal to 0. Please note, do not crucify me with words that I've said which are true. The second derivative cannot be equal to 0 if and only if we are focusing on testing stationary points. But if it's other things, for example, you have been given the equation y is equals to x, and you are told to differentiate and get the second derivative, you just write it as 0. Nobody will penalize you because it's true. That's what has to be done. So let's get various examples. We shall pick the 2 examples that we had. So the 2 examples, we shall work with them so that you may see that this method also works for the other one, so that you don't say, oh, he used 2 different equations so that to be able to prove us this. So we haven't proved. So I want to work with the same question so that this one is proved, that the method is correct. So I believe you have your answers with you of the previous workings. So let's get to this one. Find the turning point of the curve y is equals to 2x squared and ascertain its nature. You may go ahead and try working out on this. Afterwards, I shall also guide you in what I have here. Believing that you have something now at hand, the gradient function is basically 4x. The turning point, you'll get it by equating it to 0. And you'll find that our turning point, we got it to be 0.00, which was basically our origin. So that is the turning point. Now, what about now the nature? The nature will be gotten by getting the second derivative, which is d squared y over dx squared, which is 4. I believe you can be able to see how to differentiate that. We are differentiating this again. So after differentiating this, you get this. So the second derivative is found by differentiating the gradient function, which will come to this. So notice 4 is greater than 1. So greater than. Start thinking in small values, and small things are minimum. So basically the turning point 0, 0 is a minimum point. What did we get previously? Let's continue. Second example. Find the turning point of the curve y is equals to a third x cubed minus a half x squared minus 2x. Go ahead, find the turning point and ascertain its nature. Now, supposing you have something at hand by the use of the second derivative, I believe all these we had covered and found out that the turning point is this particular value. Now, what about our second derivative? If you differentiate this one now, you'll notice that you have 2x minus 1. 2x minus 1. Now, here you cannot start bringing out the greater than or less than thing because you still have an unknown. So we have x. So the second derivative here will substitute for x. And what is x? X here is basically the turning point. But notice here we have 2 turning points. So we are going to basically substitute each of the turning points simultaneously. So the first case, at x is equals to 2, the second derivative will be 3, and 3 is greater than 1. So it means the turning point is a minimum point. So greater than. Start thinking in small values. Minimum point. At x equals -1, our value here shall be -3, which is less than 1. Less than 1. If it's less than 1, it means I should think in greater values. The turning point is a maximum point. Now let's get back to curve sketching and combine all that we have learned to be able to sketch a curve. To sketch a function, it's shown on the xy plane by first finding the stationary points. Now, it's either stationary point or stationary points, depending with the function that you're working with. If it's a quadratic function, it shall have only one turning point, which is the stationary point. If it's a cubic function, it shall have two stationary points, and so on and so forth. The second thing you should be able to get is the y-intercept. And basically, you know, the y-intercept is basically the coordinate when the curve crosses the y-axis, and happens when x equals to 0. Next is the x-intercept, whereby the coordinate, you find the coordinate when the curve crosses the x-axis at y is equals to 0. Notice these three critical points must be shown on the sketch. So when you are sketching your curve, these three must be shown at your sketch. Now, key features for curve sketching: 1, turning point; 2, x and y intercepts; 3, you have to label your curve. Please notice that you have to label your curve. Now let's head to sketch our curve now. For example, sketch that curve. Y is equals to 3 minus x squared minus 2x. You may go ahead, try working out what we have just said and the steps that you have given, and try solving this particular equation. Whatever you shall have missed shall be a stepping stone towards you understanding the concept even better. Assuming that you are already done, start by getting the turning point, of which our turning point shall come from the gradient function. And that gradient function, if we get the value of x, we shall substitute it into the equation, then find the turning point. And basically that is our gradient function. So if I equate it to 0, x will be equal to -1, because we are basically focusing on the turning point. At the turning point, the gradient is 0. So when x is equal to -1, y will be equal to 4. If I substitute that into the original equation, y is equal to 3 minus x squared minus 2x. So if I differentiate the second time, you'll notice that I'll have -2. And -2 is less than 1. Basically, I'm working now with what? A maximum point. Maximum. Believe it makes sense. So at x-intercept, when y is equals to 0, then if you solve that using your quadratic formula or other formulas that you know, completing square, matrix, all of them, you'll have that. So basically the point that you're working with at the x-intercept is -3, 0 and 1, 0. At y-intercept, x equals to 0. So basically my y value is 3. So that means at the y-intercept, the point you're working with is 0, 3. So with all these particular points, we can sketch our curve. Starting with our axes, we have at point 4, and you have point -1. If I extrapolate that, I'll draw that particular first cross. Now when you're curve sketching or drawing any curve somewhere or a line, don't use dots. Use the crosses, because the examiner wants to see, did you get that exact point? And if you draw a dot, the dot will tend to be swallowed up in quotes, swallowed up in with the thickness of your line, the particular curve, or basically that line. So if you draw the cross, it shall be able to be visible even when it's being marked. Then the second point is at point 1. Now I'm sorry for this one. This is point 0. It must be drawn, or it must be shown. So that is point 0. So that's my second cross point, and the next point is at negative 3, 0. So I'll basically now draw my curve, join everything there, and I should never forget to label my curve. Now notice something. What if now I have a curve that has 2 turning points? So I'll basically have my axis like that, and then for example I can come about. For example, you have that point, and then for example it came again to this point, and that was another turning point. Then another thing you got was the x-intercept. You found that the x-intercept was here, the other one was here, the other one was here, and then the final one was here. Basically the y-intercept will basically be at this point, so you'll have no challenge with that. You basically do it the way I've done, and then you just join all the points. Okay, so that is the way you shall be able to draw, and so on and so forth. So here I had 3 turning points. I've basically represented them that way, and you'll have to say which graph is this. For example, I can say this is x power n, whatever it is. So you have to label your graph. You have to state all the points and all the other things. Otherwise, success in your preparations, and may God bless you abundantly.